So we have this is our coding, our programming. Manny is very big on two things. There's not a specifically said. One is that he really cherishes the customers and the partners, and for good reason. Okay, the partners I remember. I remember there are times we had some customers had really nasty problems, and we will go complain. They'll say, you know what, this customer is such a troublemaker. Right?
Yeah,
and he's saying, they're the ones advancing our technology.
Yeah, that's right.
Okay, many truly believe the customers, their usage is advancing our technology. So we had, taken that to heart that, whenever you're dealing with customers, you want to understand how they're using it and, try to solve the problem. And instead of, just complete this has a problem. Right?
And that's actually was a big thing. He believed that most of the innovation or big part of the innovation comes from the customers.
The troublemakers, right? Particularly the troublemakers.
So it was really welcome. All these problems were really welcome because he saw innovation in those.
That's how he kept close to the customer. Because I remember he's kind of said this several times recently, but like I guess at one point in an Applix conference that Jason went to, he's always saying that, Manny was going to reveal the secret sauce of TM1. Like, what's the secret sauce? And so everyone got excited about it. And then he, listening to you guys, he kind of did reveal it, but it didn't feel that way. Where he just said, listen to your customer. They'll tell you what you need to do. And then he was saying, don't just fix the problem. Like he said, step back from it, like you're saying, and try to really understand the problem and how it applies in a more general sense. And then he said, and then repeat for 30 years or whatever is what he said. It's like, and then everyone's like, oh, it was kind of a joke, but he was giving away the secret sauce in a way there, wasn't he? So,
it is, and it tells us that you need to delight your customers. So, I remember when you go to customer meetings, right, like those user meetings, and oftentimes we'll reveal something that will improve performance, oftentimes by orders of magnitude. Okay, not just like, it's not like 40%. It's like, maybe 2 orders of magnitude, So he's telling us, do things, imagine that, this thing you do is going to help a lot of customers by orders of magnitude. And that's important.
Yeah.
And you don't get to know those things unless you know how customers are using your stuff. And so it's really very well partners is so very, very important. I don't think he ever had an ego to say, wow, there's a partner thing, but he really listened to see their innovation, what they bring to the table, and how we can support them. Because I remember we had many partners come to our door. I remember Chris Richmond come to our office, Freelander, Breakaway. They come to our office to bring both their solution and their problem. And then we will discuss.
Like literally to your door there in New Jersey or something.
In our office.
Oh, yeah.
Literally in our office.
They come and hang out with you guys there, huh? Okay.
Oh, yeah.
Yeah, they do.
What kind of things are they talking about? Was it performance or just front end?
Well, whatever they needed.
Whatever they needed, but most of the time, for example, like the Cuber thing we're talking about.
The what?
The Cuber, the TI.
Oh, TI, yeah.
That, we just did not make it up.
Qbert?
No, it's called the Cuber. Quber.
Oh, Qber, okay.
Yeah,
Right.
it's called the Qber.
Ah.
And that's one of the earlier Java they did. Essentially saying, we create a function called the Qber, right?
Yeah,
All you do is
that. Wow, I remember that was one
he
time.
doesn't remember.
No, I just remember that was one time that Manny wasn't at the office, and then these 2 guys, I think it was from Rebelwood.
Yeah.
They came to the office, and I think they were taking the opportunity. Manny wasn't there to go into my office and say, cook something up. so that because they needed that.
Yeah, the basic idea is that they have a data and you have a specification in the function.
Yeah,
and it will build all the dimension, the cubes, and know the data for you.
And they say, right there in the office, we cooked that cuber thing.
Yeah.
And then they left, and then I went to Manny and said, Manny, they want this, and then they say, okay, fine.
Yeah.
And that's how it was born. Yeah.
Before you used to do it through the spreadsheet. You used to
yes.
add
There's the import through the spreadsheet, and it was much slower because you have to read everything into the spreadsheet and then process it, doing DBR, DBS, or whatever.
Cell by cell.
Yeah, it was a cell by
cell
cell,
by cell.
and
By this stage, though, Sinper had sold to Applix. Is that right?
Yes, I think so. Yeah.
I don't
The
know.
sale happened in 98 or 97?
96. End of 96.
End of
Version
96.
7 was TI, Cuba.
Yeah.
Oh, no, the Cuber actually existed in 6, I think. But the TI itself did not exist until 7.
So Cuber was like a forerunner to
Yeah,
Turbo
it was just
Integrator
like
or
a
something?
function.
It was just a function.
You
Yeah.
imagine it's like you know how TM1 has those called macro functions? Before 7,
But it
all
was
the functions.
it was an Excel function.
I think
Well,
it
it was
Excel.
also in Excel, but more important is, it was
Well,
Excel.
in VB.
In VB.
Because
VBA.
the API,
In
the API
VBA.
was the API was kind of formalized in version 7, right?
Yes,
Wow.
it was in version 7. Yeah.
Okay, there is a API 1.0 that is the what they call the universal API. Was actually the macros,
All the
like
macros, yeah.
DB Next,
The DB Next macros.
DB Tab. Those are all part of it, and the Cuber was built as one of those. Okay,
Yeah.
but the 7 is the one we did a new API.
API version 2
2.0.
or the C
No, the
API.
API. That's the C API. Version 2.0. That's the C API.
That's the one with the IOUs.
Yeah, that's the one with, because the macro ones are powerful. A lot of people use it, but it was centered around the people using it in Excel
Yeah.
with the VBA and stuff. It has another inefficiencies, and also not granular enough. And so we built this new C API. It's almighty powerful.
The C API is a good example of the generalization, abstraction, type of exercise, where basically it's build an API where you don't know all the answers. So every single call is a promise. You send all the promises to the server, and the server resolves them and gives you the results. Before that, you have to go one by one. You go to the server, you get an answer, and then with that answer, you build the next question, send it to the server. So how to generalize these bulk operations going to the server with promises. And today it's called promises in JavaScript and other languages. Manny called them IOUs.
Yeah, we call it IOUs. Yeah.
Right. So did you think he invented the idea of promises with the IOUs back then?
He may have. I don't know.
He may have, but we don't know. I mean, all we know is the world that we live in, that we never, it's something originated. It's not like we're copying anybody.
Yeah.
Was there anything like that just like blew you away? Like one day was like a massive light bulb moment for you or something, where you were just sitting there and like somebody had a great idea, whether it was Manny or one of you, that just never
well,
seemed
I mean,
genius, or was that one of them, the IOUs?
I mean, to me, IOUs was kind of a. I mean, I was tasked with writing that API, like send everything in bulk. I said, but how do you send all these things? I don't have the answers yet. How? Yeah, you have to give some type of IOUs. I mean, you have to send some type of chain of requests inside the call, and resolve it on the other side. And it was like, oh.
Right.
I guess that's a light bulb moment.
Right, that's
mean,
the solution. And then implementation was really tricky. I mean, it's not only chaining the request in one call and then resolving that and returning back, because those today is called protobuf. Again, another coined technology or protocol that people use today, but back in the day, there was no reference, right? So you have to, and the implementation was tricky, and also in the middle of that, we had Windows machines talking to Unix machines, and they have different architecture. The little Indian architectures. So we have to resolve all those things, and then also do the conversion in the middle of the protocol. So it was all kind of
Yeah, Server 7 has, I mean, I think for all the releases, we participate in Server 7 is, clearly the most revolutionary in terms of what we bring in. Because we know from get-go is going to do a new API. But we also know this is the version we're going to do multi-threading. And none of us knew anything about multi-threading at that time.
Spreading.
Threading.
Threading.
Multi-threading.
Multi-threading.
Multi-threading, yeah, okay.
Because before that, the server is only serve one client at a time.
Yeah.
Okay, you can serve thousands of them, but there's only one at a time. Yeah, but Server 7 is the first one to do that. And we had a lot of trial and errors.
Was there a lot of rewrite of the engine piece there? Or?
Well, well, I would say there are several things. The basic principle is not different. I think we start with after some research, we come up with it's going to be reader-writer locks. Okay, multiple readers and exclusive writers. That we had it from the beginning.
But I think the reason why we went that route was the OLAP benchmark. Right?
No, that's not because of what a benchmark.
We were trying to beat, because I remember going to the lab.
That's with a 6.
Yeah, but we went to this lab every week to test the performance.
So what exactly? Sorry, what was the OLAP benchmark? So they were just.
There was an OLAP benchmark, and we're competing with S-Base. And there is somebody.
Is it like an independent
Yeah, it was an
organization
independent test. They give you the data and they say, hey, you have to perform all these operations and this independent arbiter, which was, I think was AT&T or a big company.
NTSC or something. NTSC.
Yeah.
Or,
I mean, they have to make sure that you are running this according to the rules, and they provide the results. I mean, how many transactions per second? I don't remember exactly what was
so
the
why did you
KPI.
guys start doing it? Were you?
Well, there's somebody who's interested because S-Base published something, and there's somebody who's interested to help with TM1 to do it, and so they came around and we started with 6.
S-Base had already published some benchmarks or
Yeah,
something,
yeah.
so you guys were like, we can do better than that?
They wanted to show that TM1 was
Well, I'll tell you a little bit story. With the Server 6, we started to do this. I mean, in terms of performance, in terms of actual getting result and all that, we just beat them like, no mercy, right? I mean, they're not even close. And they have a big cube. They have to do pre-calculation.
You just crushed S-Base back
crushed them like nothing. But what they found is that we're not quite to the standard.
Oh, because of the client cache and all that.
Because we are at that time, we don't have Server 7.
Yeah.
All the operations are through macro API. And the macro API had intelligence on the client side.
It had to be server side.
Oh, yeah, they wanted everything has to be on the server side. So clients, a dumb client, don't know anything. You have to always ask the client.
Yeah,
Okay,
client.
and it's not possible for 6. Okay, because we are what we are, right? All those operations, DB tab. So you have a dimension structure on the client side, and when you're traversing, I mean, business-wise, it did not matter. It's the same application doing the same type of benchmark. We are just faster, but they're saying, okay, but you guys are not doing everything on the client, right? Which is, to a degree, is valid. I mean, not from the business user point of view, but from the purely technical point of view, that's what they want. I think Server 7 is a part of the thing was doing this to all the calls goes to the server.
Right.
And come back to the client, and the client never have any intelligence about your dimension structures and all that.
So then you did the benchmark again at that point, like.
I don't know who did.
Yeah, we did, and we beat the competition. And,
I think at that point, at some point, it just become not important anymore.
Yeah.
I don't know if somebody did. I think somebody did.
Were you using it in marketing or something? Like, were you putting out flyers, like stuff like this, like going like, "Hey, fastest thing ever"? Or something?
I don't know who did, but there's people who did this with us. They are the one who published it. What they also found, they don't want to admit, is like they're saying TM1s have a limitation on the size of cubes and stuff, right? They always people always trying to say it's in memory, therefore you have a very severe limitation.
Yeah.
What they don't tell you is the same table, same set of data, okay, you put in Essbase and others, it's 10 times bigger.
Yeah.
Okay, TM1 because you don't store calculations, you don't store consolidations.
It's very efficient, yeah.
The only thing you have is the raw data. It's actually tiny. So you can have 10 times smaller. Okay.
Yeah.
Now, if you think about it, these days people are going back to, client should not be all purely dumb. Why you should not have some intelligence on the client side? You could be faster.
Yeah.
Why shouldn't you?
Yeah, I guess. Yeah, I mean, we had customers who had, had technology that was sold to them where they go like, we can scale to as many servers as you want, and like that made sense to IT people. And like we had one customer who literally had to run their planning system for like 33 users, had 100 servers that they were running with, and like you could do that easily in a very like on one server in TM1, like in a very like normal size server too. It was like, so I mean we saw that you were saying it was like it'd be like 10 times like. Sometimes way more than 10 times
yeah,
the
that
size
has nothing
of
to
what
do
TM1
with the
was.
intelligence on the client side. It's just the architecture of the TM1 storage. Okay, you don't store anything unnecessary. It's all need for values and a empty dimensional structure, and that's just
You can only query what's being asked for.
right.
Yeah.
Well, you do get a benefit as time goes by. All the calculations get stored as it's being calculated. And what we call the calc cube, right? Comes to the calculated cube. So those are stored all the calculated values through rules. So as the time goes by, if you don't invalidate your data, you're getting faster and faster. And our customer notice it because they start the day, start querying. By the end of the day, they're getting faster and faster and faster. Okay, so since already computed. As long as you provide it, you don't go change your value and everything got to recalculate.
Yeah, invalidate the cache and you start from
That's
zero
right.
again.
Yeah, I mean, I guess when the 64-bit computing became kind of mainstream, that was kind of, from what we could see, that was where TM1 went crazy. Like the lid was blown off the top because people, I guess, were criticizing it, saying you got this only so much you can do, even though you could fit a lot into it. Like it went crazy at that point, right?
It's a marketing. Kind of like our opponents, they can use kind of a marketing term to say, oh, TM1 limited this, TM1 limited that. In reality, it never was an issue.
Yeah.
But the 64-bit was important regardless.
Yeah.
Because we are pure memory, and the customer is moving, getting bigger and bigger applications.
Wasn't Solaris already 64-bit like sooner? Didn't they?
Well, they had when we started, Solaris was still doing the 32-bit systems.
Yeah.
Okay, but they did have 64-bit. I think the first 60-bit system we were dealing with was actually HP.
Right. Okay.
Right, but we were pretty early, because when Intel started to do the 64-bit, they started with a titanium chip.
Yeah.
We were actually early on working with Intel and Dell, trying to get the 64-bit going, and we actually had the server running and everything. But that one did not quite take off.
Version 8 when 64-bit came out? Or was that?
Yeah, I think it was started probably somewhere at 7, but it's really 8. That it's kind of like as soon as like the Windows have the hardware available, we are ready for it.
Right.
Because the part of the reason why Windows, okay, there was a Windows has a Windows system, or not the Windows system, the Intel chips actually has a inherent advantage for TM1. And a lot of customers get confused about like big Unix systems at the time versus the Intel systems. Intel systems is much cheaper as a commodity. So you can get it for a few $1,000, maybe $10,000. It will run much faster than the $250,000 system.
Yeah.
And it's because that the Intel chip is optimized for integer operations, and TM1 is mostly integer operations, because all we're doing is traversing the tree and looking for your values. Okay, there's not a lot of fancy computing keep going, like not like AI keep churning on some computations. it's really looking for your values. So that's all integer calculations, and there, the Intel's chip is superior. And so that's why the 64-bit, the other system already had it, and we already have our code is working, but it doesn't take off until like Intel really have chips that run 64-bit.